In this question, we are being asked to deductively show how angle D, the exterior angle, is actually equal to the sum of the two opposite interior angles A and B. Because so much of the relationships that we already know about triangles and angles and parallel lines and stuff come from the relationships in parallel lines, I'm actually going to construct two parallel lines around my triangle. This will actually allow me to see a whole bunch of relationships that I wouldn't normally have seen. Remember that so much of what we also know about the relationships between parallel lines and angles is done through the use of a transversal. So I can take a line and I can put it anywhere connecting these two or intersecting these two parallel lines, and I'll be able to form a whole bunch of relationships. Corresponding angles, alternate angles, co-interior angles, etc., etc. So I can actually start by taking a line, and let's make this a transversal on one edge of my triangle. Put over just a little bit. Why is it not letting me move? There we go. Okay, so from here we can actually find a couple of relationships that exist, one of which is that angle C here, using alternate interior angles, is the same thing as angle C up here. So I can rewrite that. Another thing that I'm actually going to notice at this point is that I can draw another transversal. I can take this transversal and I can maybe use it along the other edge of my triangle to maybe see some other relationships. Some of this stuff comes from just playing around with the angles and lines and stuff and see what relationships that you can see and going from there. Here we can actually see, again through alternate interior angles, that this angle and this angle are equal. So I can rewrite my B up here. So I'm actually able to rewrite B and C as part of what makes up that full parallel line up there. From here, it's hard to quite know what to do, but really we're being asked to compare or look at this and how it relates to B and A. Keep in mind that B and A are also written next to each other up here as this complete angle. You see any other relationships that exist? Oh, look at this. If we were to take this transversal again and actually move it back here, it's always easier when we can visualize things a little bit. We actually see something else very interesting. This angle here, using alternate interior angles, should be equal to, oh, look at this, that angle up there, using the Z rule. So we can actually show, from playing around with transversals and parallel lines, that angle D is equal to angle A plus angle B. And we can say that because of all of the alternate interior angle relationships.